This is a review for the quiz on Monday and Tuesday. So basically we're just going to review what we learned in the exploration. When you have a line, one of the things that characterizes the line is the gradient, which is the slope of the line. Now remember that the slope is rise over run. Rise over run. Okay, so the rise is the vertical part and run is the horizontal part. Remember that the x-axis is the horizontal and the y-axis is the vertical. Remember that the x-axis coordinate always comes first, the y-coordinate comes second. So, for example, if we're going to describe this point here, then we would describe that as 0, 1. Because 0 is the x-coordinate and y is the y-coordinate is 1. Okay, so let's figure out what the gradients are for these two lines here. Looking at this this line with G and H on it, all we need to do is draw a triangle at in between any two points, but it's easier to choose points that are exact whole numbers. It makes things easier, right? So the rise here is 2, and the run is 1. So the gradient is going to be made up of these two numbers, but one complication is that we always need to define if these numbers are positive or negative. And the way we do that is we look at one point in relation to the other. So if we have like point G is our first point, and point H is our second point, then we would say that the rise would be negative, because actually our first point is higher than the second point, so we go down, so that would be a negative 2. The run from G to H, it would be a positive 1, because we're going to the right. So going to the right is positive, going to the left is negative, going down is negative, going up is positive. So in this case that we define G as the first point, and H as the second point, then the rise would be negative 2, the run would be 1. So the gradient would be negative 2 divided by 1. Now what if we did the opposite, and instead of saying that G was the first point, G was the second point. So this time we're going to start with H as the first point, and G is the second point. So to go from H to G, the rise would be plus 2, right? And the run would be negative 1, because we're going backwards. So let's write the equation for rise over run here. We have positive 2 over negative 1. So we get negative 2. And here we also get negative 2. So you see that either way we define it, G is the first point or H is the first point, we still end up with the same gradient, which is negative 2. Either you put negative 2 over 1 or 2 over negative 1, but either way you still get negative 2, right? So let's take this other line. We'll practice here. So we'll take these 2 points because they're exact whole numbers. It makes it easier. And the rise here would be, that's 2, right? The run here would be 3. Now, we just need to see if they're positive or negative. Well, if we choose this point as the first point and this point as the second point, then it would be plus 3 and plus 2, right? We're going to the right and we're going up. So the rise over the run would be 2 over 3, both positive numbers. So the gradient is 2/3. What if we did the opposite and we said that this was the first point and this was the second point? Now, instead of positive 2 and positive 3, we kind of get the opposite, because to go from the first point to the second point, we need to go down 2, and then we go left 3. So in that case, the rise would be negative 2, the run would be negative 3, and, a negative number divided by a negative number gives you a positive number. So the gradient still turns out to be 2/3. So you can see that it doesn't matter which point you choose first, you're still going to come out with the same gradient. It's either going to be 2/3 for this line, or it's going to be -2 for this line, for example. Okay. Now let's talk about the equation for a line. The equation for a line can be written in a form like this, which is y equals mx plus c. Okay, and each of these variables has a certain meaning. As you know, the y-coordinate and the x-coordinate are expressed as x and y. So that means that like any point that's on the line, you could put inside this equation, and you can see that they'll equal each other, the left side and the right side. But what are m and c? Well, m is the traditional symbol for slope or gradient. So like if we were going to write the equation for this line here with its gradient -2, guess what's going to appear as m? It's going to be -2. And if we were going to write an equation for this line, guess what's going to be m? 2/3. Okay? Now the only thing we need to figure out is what is c. So c is actually, for these lines, is the y-intercept. And so first we'll fill this in, then we'll explain why. The y-intercept is where the line crosses the y-axis. What's the y-axis? Well, the y-axis, you remember, is the axis that's vertical. So where does this line cross the y-axis? Well, it crosses it there, right? Which is at the point 1, right? And what about this other line? Where does it cross the y-axis? It crosses at -2. Okay? So for here, we know that it crosses at 1, so we're going to put +1 here. And here we know that it crosses at -2, so we're going to put -2 here. Okay, so now we've written the equation for the line, which is an equation that only has two variables, x and y, and the rest of them are all real, like normal numbers or constants. Okay, so this one's going to be y equals -2x plus 1, and this one's going to be y equals 2/3 x plus -2 or -2. Okay. Now, why is this number the y-intercept? Well, the definition of the y-intercept is when you're on this vertical line, and when you're on this vertical line, look at what x is. X is 0, right? Here x is 1. Here x is 2. Well, here x is 0. So what you do is you just put x equals 0 here, and then you should get the y-coordinate, which happens to be the y-intercept. So for example, if we say for this line here, we're going to say, okay, what is y equal to when x is 0? Well, all we need to do is put 0 in there, right? And then 0 times 2/3 is equal to 0, and then it's -2. So we find out that y equals -2. What do you know? It's the y-intercept. Okay, so this formula, y equals mx plus c, is written so that the c is the y-intercept. Okay? So that was just kind of a long explanation about why c is the y-intercept. But basically, if you write the equation in this form with y on the left, mx plus c, c is the y-intercept. Okay? And m is the gradient. So that's what you need to know for the quiz.